here were some examples I was thinking of with the variation using some simulations. So here's one where you pick orange rhesus species from a population and you try to figure out how many you're going to get. So this is going to show you the variation between samples. So without standard deviation, and it plots the point here, let me do a couple more. You could have students actually do this in class and simulate it. Maybe not so much with rhesus pieces, since it's only 1 out of 4, and there aren't 4-sided die unless you get a tetrahedron. But you could do certain things that would make it correct. Or roll a dice, and if you get a 1, 2, 3, or 4, if you get a 5 or 6, you roll again. The samples don't have to be as big as 20, but this is just the idea that in between samples, and this would be a simple random sample, that you do have variation in the choices. So that's one idea. Let me pause the video and I'll tell you the second one. Okay, and so that first example would have been qualitative data, since it's the color of the rhesus pieces, or categorical data. So now this one is going to be quantitative. So essentially this one is about the length of the word, the number of letters in a word in the Gettysburg Address. So that's your population. So you can do sample sizes. So if I did this, and you see here's my sample of the words in the Gettysburg Address using a simple random sample. Let me zoom in so you can see this. And you can see that that's one sample. So let me do that again. And you can see that's another sample. Way different than the first one, but they're still representative samples of the population. And I can do another one. And you can see over here they're plotting the mean of those samples. So if students were to actually, each one of the students were to pick 10 words from the Gettysburg Address, then just randomly doing it by picking a number, because there's only so many words in that population, then they could do a simple random sample. So in other words, the students would be randomly picking the ID number for the space in the Gettysburg Address. Alright, and another one you could do is pennies, and you look at the 2-digit year on a penny, and I believe this was done before the change of the century. I think this date, I'm not 100% sure, but I think it is actually the year of the penny and the age, but I'm not sure what exactly this data was. But again, we could draw samples to show the variability, and so in other words that there is chance variation between samples, but typically they should all kind of form, or nearly form, a new mean called the sampling distribution mean. So the mean is 86.4 here. The original data was 86.7. This is 86.4. So if I do multiple sampling techniques, I am getting close, if almost identical, to the actual population mean. Those are some of my ideas about how to compare variation. Other things you could look at too would be the Park samples. Let me see if I can pull one of those up. And maybe this one could be the comparison of the two dot plots. So which airline would you prefer to fly? Someone that could be extremely late or extremely early, or do you want something that's more consistent? Let's see, there was another one here. This one, you have two exercise groups and you can compare maybe the spread. This one though is not as interesting because, well, I don't know, they both go down to about 75 and then their high is, they look very similar. But at any rate, those were some of my ideas. Hopefully that explains it.